In this video, we're going to walk through the vision pathway, and so I want to draw it out. Hopefully this makes or will help make sense of it if it's still a little unclear to you. Okay, remember the vision pathway is a G protein pathway. Okay, vision is actually an inhibitory pathway, which makes no sense or very counterintuitive, but that's what it is. So let's walk through this pathway. Okay, so the first thing is that we have to have light. So here's my sun, okay, and so this hits my photoreceptor. Now within my photoreceptor, we have all sorts of different proteins. Now one of those proteins is something called rhodopsin, okay? And so when light hits rhodopsin, so maybe my arrow should come here, which is in the photoreceptor, it breaks apart into retinol and opsin, okay? Now at this point, what's gonna happen is that they split apart. Retinol is gonna do its thing, but we're more worried about opsin. So opsin you could almost think of as a neurotransmitter in this case. It's not, but that's how we can think about it. And so what opsin does is it comes and it binds to transducin. Transducin is a G protein, okay? And what this does is this activates, opsin activates this G protein pathway. Okay, and so if you remember, when a G protein pathway is activated, what happens is we have GTP come in and GDP leave. Okay, now remember, G protein is made up of alpha, beta, and gamma. Okay, so once this G protein is activated, well, then what's next? So the typical pathway, which is what this is that GTP and alpha leave. And so I'm going to just move it over here. So GTP and alpha leave, and they go bind to a protein. Well, in this case, they bind to something, to a protein or an enzyme called PDE. Okay? Now remember, I like to think of enzymes as hammers. Okay? And so whether or not how accurate that is another story. But here's my hammer. I'm not going to draw it in a hammer. But what PDE does is it causes something called cyclic AMP to be broken into, or excuse me, cyclic, this would be cyclic GMP into GMP. Okay, GMP is a key, or cyclic GMP is a key, and so PDE is effectively breaking that key. And so what happens as a result of us reducing the amount of cyclic GMP that's available, we close sodium channels. And so we have an increase in, actually let's do it this way. We have a decrease in sodium influx, okay? Because cyclic GMP is the key for sodium channels. And so sodium can rush in as long as we've got cyclic GMP available. But with this vision pathway, we're actually breaking the key, which closes the door, which means we don't have as much sodium going in. And so this leads to hyperpolarization. Okay, so hyperpolarization. And by hyperpolarizing the photoreceptor, it releases less glutamate. Okay, glutamate is what's released by these photoreceptors, and they signal bipolar cells. Well, glutamate inhibits bipolar cells, and so if we release less glutamate, bipolar cells can do their job, which is to activate the ganglion cells, and the ganglion cells are then able to do their job, which activates your optic nerve, and your optic nerve goes, oh, I'm seeing something. Okay, so just a reminder that vision is an inhibitory pathway. It equals, or is very similar to the G alpha I pathway. Okay. In other words, and what are we inhibiting? We're inhibiting cyclic GMP, all right? And so by inhibiting cyclic GMP, we're causing the cell to be hyperpolarized, which prevents the release of glutamate, okay? And so that's what you need to know, and we'll go over this in class and talk about it a little bit more in detail.